In this discussion video, we will do some true-false practice questions. So I want to look at problem number 5 from worksheet 9, which says true or false. If it is true, explain why. If it is false, give a counterexample. And I want to look at parts A and B. So first, I want you to take 6 minutes to try these two questions. So pause the video for 6 minutes total. 4, 3, 2, 1. Pause it for 6 minutes to try A and B. Alrighty, so hopefully you did that. Hopefully you paused it for 6 total minutes to try A and B. Let's talk about them. Alright, so A says, if f prime of C equals 0, then f has a local extreme point at C. So remember, local extreme point means either a local max or a local min. So if the derivative is 0, does that mean that f has to have a local max or a local min? Well, let's break it down. If the derivative is 0, that means the slope of the tangent line at x equals c is 0. That's what the derivative tells us. And that means I have a horizontal tangent line. So if I have a horizontal tangent line, does that mean that at that point I have to have a local max or a local min? And the answer is no. So this is going to be false. So let's give a counterexample. So here is a counterexample. And I think for something like this, it's easier to draw a picture rather than give a specific formula, although I would say even a formula isn't too bad. Okay, so y equals f of x. So I need to draw something that's got a horizontal tangent line somewhere, so it gets flat, but that point where it gets flat isn't going to be a local max or a local min. So one example is if I have a function sort of like curve, get flat momentarily, and then keep going up sort of like this. All right, in this picture, f prime of 0, when x is 0, that slope is 0, but f does not have a local extreme point at x equals 0. So this shows that this statement is false. Okay, and it turns out if I wanted to give an example, that was a formula. This picture actually gives me an idea for what that formula should be. If I were to take the x cubed graph, that looks essentially exactly like this, and that would be a counterexample. All right, let's move on to part B. B says, if f has a local extreme point at C, then the derivative at C is 0. Alrighty, so one of the things that this might remind us of is one of the theorems we stated in class, and that was Fermat's theorem. Fermat's theorem, let's remind ourselves what that says. It says that if our function f has a local extreme point at C, a local extreme point at C, so that means a local max or a local min at C, then it tells us something about the derivative. The derivative is 0 or is undefined. So this statement in B is saying, okay, if there's a local extreme point, then the derivative has to be 0. But Fermat's theorem says, hold up, that's not exactly true. The derivative is either going to be 0 or it's going to be undefined. So there's another possibility that part B is not talking about. So that's making me think this is false, and let's draw a counterexample picture. So here is a counterexample. And again, just like with the last one, there's a bunch that I could potentially give or draw. So I'm going to try to draw a picture that kind of uses that idea from the last one. I need a point on the graph that's going to be a local extreme point, but where the derivative is not 0, where it's going to be undefined. Okay, so let me draw something that has kind of a corner at a high point. This would be a local max. Maybe I'll say this is at 3. But the derivative is going to be undefined here. It's not going to be 0. F has a local extreme point at x equals 3, but our derivative, but f prime of c, our derivative is undefined.